Hello everyone, Dr. Daniel Barth here from the How Do You Know program. I'm participating with my colleague, Professor David Sederberg from Purdue University, in a project that we're calling International Measure the Earth Day, or the Eratosthenes Project. You may have heard of Eratosthenes in school. He's the ancient Greek mathematician, 2,500 years ago, was first to successfully measure the circumference of the Earth to modern accuracy. Eratosthenes simply used a stick and a ruler and measured the shadow of the stick as it fell on the ground on the summer solstice in two different cities almost 1,000 kilometers apart on a north-south line. This gave Eratosthenes the solar angle at two different points on the Earth, which allowed him to measure its circumference accurately. He got within 2% of the modern value. Now, we're going to be explaining how Eratosthenes measured the Earth in a later video, but today we're just going to show you how to make your own instrument to help us measure the Earth. Our idea is that we want thousands of observers, if possible, from around the world who watch the How Do You Know program, Global Star Party. We're also going to be circulating this to schools throughout, well, as far and wide as we can manage. And if you know someone who teaches or a student who's in school, we hope you'll give them the link to a video so they can participate with their classmates as well. We're going to be collating all of this data together and seeing if we can measure the Earth accurately. We'll also be publishing the data, both the raw data and the spreadsheet app, so that you can go ahead and perform your own calculations later. Now, there are two essential methods for measuring the Earth this way, and in one, it's extraordinarily simple. You just need a dowel rod and some kind of a level, but that requires two people to do. Today, we're going to be discussing the one-person measurement method so that if you're on your own, you can participate in this exciting international project. Now, you're not going to need very much for this method. A simple camera tripod, one that has a center head that will both raise and lower, will be needed. Apart from that, you need a dowel rod. This is a 3/4 by 36 inch. If you're elsewhere around the world with metric measurements, something about 20 millimeters by 1 meter long will be just fine. The exact length of your dowel rod doesn't matter. We'll be taking that into account when we collect the data. The other things you're going to be needing, and I'm hoping you can see these, one is a screw eye. And you can see this is the kind of a screw eye that you put in to hang things from. You may be thinking of a cup hook, which you put underneath a shelf to hold a coffee cup. That would work just as well. We've got a 1/4 nut here. Why? Because our camera tripods almost all have a 1/4 fitting. We've also got a common ruler with a hole in the end. I'm using a steel ruler here, but a plastic or wooden one should work just as well. Let's show you how this works when we put it together. We're going to be using our 1/4 nut to attach our steel ruler to the top of our camera tripod, the tripod head. This will allow us, when we attach this to our tripod, like so, there we go, and it locks in. Now we've got a platform that extends about 25 or 28 centimeters off the camera tripod. Why do we do that, you ask? Well, when we're going to be measuring the shadow of the rod, we don't want it overlapping the shadow from the legs of the tripod, so we get a nice clean measurement. You can see what we've done here with the dowel rod. We've taken this eye hook, and this thing is about, 15 millimeters wide. The size of the hook doesn't really matter. And we've screwed it into the end of the dowel rod, taking care to get it as close to the center as we can. And we've got a little loop of string, about, maybe 2.5 or 3 inches, about 5 to 7 centimeters. All we're going to do here is we're going to take the loop of string and we're going to use it to hang the dowel rod. Now, you can see the dowel rod swinging back and forth slightly, and this is essentially a pendulum now. When this dowel rod swings back and forth, eventually it will come to rest like all pendulums. And when it does, it will be perfectly vertical because we've got the point of support that runs through the center of the dowel rod, and that runs through the length of the dowel. This will take a couple minutes to stop swinging, but I'm going to speed it up here and see if I can get it to stop. There we go. Now, with the pendulum dowel stopped, we're going to very carefully and gently lower the dowel rod just until it touches the ground. We want it still. There we are, and I'm going to lock that in. We want this still with the rod just touching the level ground surface. We want this because this gives us a perfectly vertical rod. Now, we're going to be watching the shadow on a sunny day over a piece of level ground, and we're going to wait till the shadow crosses the north-south line. We'll explain how that works and Eratosthenes' message in another video. And here in northwest Arkansas, we've had 30 centimeters of snow last week, more than a foot, and now today we're getting ice. We're having an ice storm. So obviously we haven't had a sunny day in a couple of days. The next time we get a nice sunny day, we have a nice place here on the ranch where we've got a nice big flat concrete slab where we can go ahead and set up this method and show you exactly how to measure the shadow and what data you need to take for us. I hope that you'll consider participating in International Measure the Earth Day. It's actually a week long, March 12 to 18, so we can give everybody as much time as possible to give you a good chance for a clear weather day. And we're going to go ahead and collect that data. As we said, we'll be grouping it by time zone and by day, and we'll be using all these sets of data. The more data you have, theoretically, the smaller your error should be. And so we hope that we're going to be bettering old Eratosthenes' measurement, which came within 2% of the modern measure of the Earth. Thank you for watching, and I'll ask you to watch for upcoming videos on the Astronomy for Educators channel and also on the Explore Alliance website, where we'll be showing you how to do the two-man simpler setup, which just takes a stick and a level, and we'll have a video as well once we have a sunny day, which will show you exactly how to take your measurement. Thank you all for watching. Clear skies.